student, today we are working with absolute value. Its graph is a V shape and the equation uses two cases. Our goal by the end, you can first graph y is equal to absolute x minus h plus k using the vertex h comma k, and second state the range y larger than k, and third solve absolute value equations and reject extraneous answers. A here, without using your calculator, graph y is equal to absolute x. So what can we do here is we know that the parent function makes a v, so vertex it will be here is 0, 0. So we will plot a mini table like x and y. Y is absolute x, so when x is minus 3, it is 3. When x is 2, it is. So we'll plot a graph 0, 0, minus 3, 3, minus 2, 2, minus 1, 1, 1, 1, 2, 2. Okay, this is for y is equals to absolute x. Okay, then using your calculator to generate a table of values, graph the other two absolute value above and label each equation. So we're done with this and we have another two. So for y is equal to absolute x minus 3 plus 2, we will then form, from here we can form h and k, which is x minus 3 equal 0, x is 3, and then y is 2, which is our vertex h comma k, which is 3, 2. And then we know that it shift right 3 up 2. So for the next graph, shift right 3 up 2. So this is our vertex. The first one, vertex is 0, 0. So we will draw a table. So pick x and y is equal to absolute x minus 3 plus 2. Is minus 2 plus 2, which is 2 plus 2, which is 4. Okay, so next point, you need to substitute again. So I will have 2, 3, 3, 2, 4, 3, 5, 4. So we can plot 1, 4. 1, 4 will be here. 2, 3, 3, 2 is our vertex. 4, 3, and 4, 3 is here, and 5, 5, 4, 4, 3 will be here, and 5, 4. So this is 4, this is 5, this is 4. So we draw a line. Okay, this will be y is equal to absolute x minus 3 plus 2. Okay, the first table done. Now we go to the last graph. We still need to plot x and y. Y will equal to x plus 1 minus 4. So from this line, we know that this is your h and k. So we'll put value minus 3. So if we put in this equation, it gives you minus 2, minus 2, minus 3, minus 1, minus 4, 0, minus 3, 1, minus 2. So we will just plot it 0, minus 3, 1, minus 2, then minus 1, minus 4, then minus 2, minus 3, minus 3, minus 2. So vertex should be minus 1, minus 4. This is vertex. And this will be y is equal to absolute x plus 1 minus 4. This graph. So here is our vertex, and the other one here is 3, 2. This is 3 vertex. And this is the equation. Compare to y is equal to absolute x minus h plus k. Here is it. So you can say that the parent graph is 0, 0. So from here, this is 0, 0. And now here is x minus 6 equals 0, x is 6. So hk, x is 6, y is minus 8. So we can say that from y is equal to the first one, original, it will be right 6 down 8. The new vertex is this. So that the graph of y equal to absolute x will need to be shifted 6 units to the right and 8 units downwards. Question asks for range, so you will have your value of x is 8, y is negative 3. So y is negative 3 larger than negative 3, 2. So the answer should be option 2. Okay, question 3 asks us to isolate the absolute value and then check the right side. If it's negative, no solution. Write two case inside equal right side or inside equal to negative of right side. Solve both and check, especially if variables are on both sides. So if a absolute x equal 8, the absolute value is already isolated. Set up the two cases, which is x is minus 8 or x is 8. So solution set will be 8 minus 8. Only numbers 8 units from 0 have absolute value 8. So next for b, you will need to isolate it. So you have x plus 7 equal 3, and then x plus 7 equal minus 3. So this absolute will split and give you 1 minus 3 and 1 3. So from here you will have x is 3 minus 7, x is minus 4, x is minus 3 minus 7, x is minus 10. So you have x minus 10 and x minus 4. Okay, solution is these two. So C, you have 2 absolute x equal 20. Isolate the absolute value. So you have 20 divide 2, which is 10. So you need to break up these two into 2, 1 minus 10 and 1 10. So x is minus 10, x is 10. Okay, next D, you have 3x minus 4 plus 11 equal 32, then minus 11 both sides. You will have 3x minus 4 equal 21. And then you divide 3 both sides, you will have x minus 4 equals 7. Okay, for exercise 4, asking for absolute value, equation has no solution. Which one is it? So absolute value is never negative. If you isolate absolute and get a negative number, say no solution. So for the first one, question 1, if we have 5x minus 3 equal 8, so we will plus 3 both sides, will become 11, 5x, and then we divide 5 both sides, so we have x equal 11 over 5, which if we want to open this, become split into 2, so meaning x is 11 over 5 minus 11 over 5. So solution exists. So this is 1. If I have 2, number 2 says that 4x plus 3 plus 6 equal 2. So we will minus 6 both sides, it gives minus 4 here. It is 4x plus 3, and then we divide 4 both sides. So it gives me negative 1x plus 3. Okay, so now I need to split. Okay, from here, you can see that you have absolute x plus 3 equal minus 1. It is a negative, so no solution. Minus 1 is a negative, so no solution. You can say that an absolute value cannot be negative, thus this equation cannot have a solution. 1 equals 0, x is 1. Okay, so vertex will be 1, 0, h comma k. So 1, 0 here. Okay, this is 1, 0 vertex. So another one is this. Y is equal to x minus 5. So it's a line with slope 2, y-intercept minus 5. Need to find the x and y for, I have two different tables. One is to find absolute. And then one more is to find, this is absolute, this is linear graph. X, y is 2x minus 5. Okay, so if x negative 2, negative 1, 0, 1, 2, 3. So if x is negative 2, y is negative 2 minus 1, which is absolute minus 3. Absolute of minus 3 is 3. Okay, next. Here is 2, 1, 0, 1, 2. For linear, next 1, 0, 1, 2, 3. So substitute inside here, 2 minus 2 minus 5, you will get minus 9. Okay, so next, minus 7, minus 5, minus 3. Everything you need to calculate one step by step. Minus 1, 1. Okay, then from this table, I will draw my graph. So the range is from, for x is highest 3, lowest minus 2. This is for x. Another one is, you have highest, here is 3 and 2, 0. And then for linear is from Lowest will be -9 and highest will be 1. So you can say that your graph should draw from 0, 1, 2, 3, -1, -2, -3. For y is, you will need a value from 1, 2, 3, and then -1, -2, -3, -4, -5, -6, -7, -8, -9. Okay, so plot one by one. First coordinate is -2, 3. -2, 3. And then you know that from this equation, vertex is 0 for y 0, x is 1. So 0, 1 here. y0, x1. Sorry. x1, y0. x1, y0 is here. 1, 0. Okay, then 2, -1. Second point, -1, 2. -1, 2 here. 0, 1, 0, 1, 1, 0. This is vertex, right? 2, 1, 2, 1, 3, 2, 3, 2. So you can see that this is our absolute graph. Connect all the points. Okay, so we can say that this is y is equal to x plus x minus 1. Label it. Okay, next, second plot is for the second graph, which is the linear graph. So -2, -9 will be here. On -1, -7. Okay, so I have no intersection point yet, so that's why I need to find x4. What is x4? x4 is y equal to 4 minus 5, which is 3. So here is 3. Okay, next from here I also need x4. x4 is 4 minus 1, which is 3. So here also 4, 3. 4, 3. So same here. So then this blue line will go like, because my line is not accurate, you can draw a more accurate graph. Okay, by using your graph, please draw a okay. Just now I show you how to actually plot a real graph, but just now my drawing is not accurate. You can draw in a accurate graph paper, and this is how you will have the graph. Intersection point 4,3, and this is 2 line. Alright, so since the two curve intersect at only intersection at 4,3, solution is x equal 4. Right, so solve this algebraically. The b, we need to split this into 2, which is we have plus minus 2x minus 5. So first one, we will have 2x minus 5. Second one, we will have a minus sign in front. Okay, so here we solve it, it will become minus 2x minus 5 plus 1. So it is minus 4 minus x, x is 4. The other one will be, we expand the bracket, x minus 1. Okay, next, x plus 2x, 5 plus 1, 2. For C, you need to put inside the original equation. So we try to put 4x equal to 4. Put inside x minus 1, right? So it is 4 minus 1, and it gives you absolute 3, which is 3. So yes, it will work if you put in the right side is 2x minus 5. So try to put 4 inside. 4 minus 5, it gives you 3. So it works. So both equation, you got 3. But x is 4. But when x is 2, for x2, x minus 1 is 2 minus 1, which is 1. Absolute 1, which is 1. So for x2, right, for the second equation, 2x minus 5, if you put 1 minus 5, it will give you minus 1. So we will choose the x4. We will choose x4 because left and right works. Because why? Because 3 is equal 3. Here, 1 is equal negative 1. So not equal. So for this one, you need to see for this type of equation, is the absolute isolated? First, you need to check it. This is already isolated because it is at the left side, only absolute there. So it is alone. And then second, you need to see non-negative condition. The right side must be larger than 0. Okay. And then we have two cases. We will split the modulus x minus 5 equal to x plus 5. One is positive. And the other one is x minus 5 equal minus 2x plus 5. Then you expand. Here become 2x plus 5 plus 5 both sides. It gives you x equal 2x plus 10. And then minus 2x both sides. It gives you minus x equal 10. So x is minus 10. Next, the other side, minus, expand the minus sign. Next, plus 5 both sides, it gives you x equal minus. Okay, then from these two, for number A, you have two value, right? You need to put inside the original. Check inside the original. X is minus 10. So, minus 10 minus 5 equal 2 times minus 10 plus 15. Okay, here is minus 15 absolute. Here is minus 15. So if you open the absolute, it will be positive 15. minus 15 is not equal. So we reject not equal, we reject extraneous. For minus 10, we reject. Next, for 0. For 0, I try to put x0 inside equation. This equation, original equation, I put both sides. I change 0 to both sides. So, 2, 0 plus 5, it gives me minus 5 equal, minus 5 absolute equal to 5. Then open the absolute equal 5 equal 5. So, x equals 0 is next. For B, you will be doing the same steps. So first you get x 14, right? So check next value. So now expand. It will be minus x minus 13 to x minus 1. Then plus 1 both sides. It gives you 2x equal minus x minus 12. Then plus x both sides. It gives you 3x equal minus 12. And then x is minus 12 divided 3. X is minus 4. So you have two values. One is minus 4 and one is 14. So you need to put back. Check in the original. In original. So this is the original. 2x minus 1 equal x plus 13. When x is 14, so put inside. 14 minus 1 equal 14 plus 13. So it is left side is 28 minus 1 equal 27. So it is 27, absolute 27. Open the absolute, it is 27. Yes, it is works. But if we put inside minus 4, so when x equal minus 4, so put inside. 2 times minus 4 minus 1 equal minus 4 plus 13. So it will give you, at the right side is 9, so solve inside the absolute. Minus 8 minus 1. It is minus 9, absolute equal 9. So open up the absolute, we remove the absolute, it is positive. So yes, it works, both works. Okay, so none of minus 4 and 14 is extraneous. So it is all accepted. Absolute values makes a V vertex from the equation y is equal to absolute x minus h plus k. The vertex is h comma k. And the range for a V opening up is y larger than and equal k. So to solve, you need to isolate, check sign. If two cases, solve and check. If after isolating the right side is negative, say no solution. If a solution doesn't satisfy the original, it's extraneous.